Throughout this course, you will learn about many important computational methods that are used in statistics, such as Monte Carlo simulation and the Markov chain Monte Carlo methods. For many of these important methods, they require drawing random samples from certain probabilistic distributions. For many well-known distributions, R contains built-in functions that allow us to draw pseudo-random samples from these distributions. The textbook, Table 3.1, contains a list of univariate probability distributions that are available in R. Here's the list of available distributions, and you can see that for each of these distributions, there's an rdist function, as highlighted in the generator column, which allows us to generate random samples from these given distributions. For example, R beta can generate pseudo-random samples from the beta distribution. R binom generates pseudo-random samples from the binomial distribution, etc. For example, if you want to draw 5 samples from the uniform distribution between 0 and 1, then you can do RUnif and supply what is the number of samples you want to draw and some distribution parameters. In this case, I want the minimum and maximum to be 0 and 1, respectively. And then R will give you a list of 5 pseudo-random samples that follow the uniform distribution. If you want to draw one sample from the normal distribution with mean 1 and standard deviation of 2, then you can do R norm and say n equals 1, saying that we want to draw one sample, and then -1 and SD is equal to 2, and then R gives you one sample from the normal distribution. To draw 3 samples from the binomial distribution with n equals 8 and probability of success equals 0.4, you can do R binom, supply the number of samples you want, 3, size, so the binomial n equals 8, and p equals 0.4. And then R will give you 3 samples from the binomial distribution. The values will be between 0 and 8 for each of them. As an optional exercise, you can go to RStudio and give these rdist functions a try. For each of these distributions, you can do !rdist, for example, !r beta, and then you will be able to read the R documentations about what are the inputs and what are the outputs. Our question for this class is, how are these pseudo-random samples obtained? And yes, these are pseudo-random samples. They are not truly random samples. A more general question we might ask is, given any kind of valid probability distribution, how do we draw random samples from this distribution? In this week, we will introduce 2 methods for generating random samples. The first is called the inverse transform method, which is also known as the inverse CDF method. And the second is called acceptance rejection method. For now, let us assume that we know how to draw random samples from the uniform 0-1 distribution. At the very end, we will talk about a little bit in terms of how to draw pseudo-random uniform samples.